Yeah, hello. Um, what we have here, it's an automatic battery charger design. Um, it's actually a 300 amp deep cycle battery charger. This charger is capable of automatically switching off the system once the battery being charged is fully charged. Um, let's go through the main parts or the main components. Obviously, this is a transformer. As you can see, it's actually a step down transformer. Yeah, that steps down the incoming 220 volts AC, steps it down to about 15 volts. And what we have here is a heat sink. This heat sink is for a 30 amp rectifier. This is a rectifier. What it does is it rectifies the AC power coming in from the transformer. It turns it to DC. And what we have here is the control circuit, the charger control circuit. Yes, what this circuit does is it monitors and senses the charge level of the charger that is being charged, the battery that is being charged. It senses the charge level of the battery and decides when to switch off the whole system and or when to activate the whole system. What we have here is an auxiliary circuit. I call it auxiliary because it houses a filter capacitor. This capacitor filters the DC produced by this rectifier, and also houses the indicator for the outer packaging. This controls the indicator of the outer packaging. As you can see here, this is one of the indicators. This is the charging indicator. This one is the fully charged indicator, and the power indicator is still coming on. And this auxiliary circuit also powers the heat extractor fan, which will come behind here. This is the heat extractor fan. It will come behind here, and it's powered from this same auxiliary circuit. And yeah, these are the main parts of this automatic deep cycle battery charger system. As you can see right now, the whole system is now almost ready. As a matter of fact, it's now 99% ready. I've done all the connections that needs to be done. I'm through with all the connections, and let me take you through some of what you're seeing here. And this is a prototype, by the way, so that's why the conductors looked a bit scattered. Is the prototype, so I hope you bear with me. As I said earlier, this is my cooling fan that cools everything here. This cooling fan, like I mentioned before, is powered from this auxiliary circuit down here, and this auxiliary circuit is powered, of course, from this transformer, from an auxiliary winding. So what we have here, like I said before, is a heat sink for my rectifier. As you can see here, you can see the rectifier. This is the heat sink for that rectifier, and it's been linked up. The rectifier has been linked to the output of this transformer, to the secondary winding of the transformer. Here is the primary winding. The primary winding, by the way, is linked to a fuse. If you can see it over here, this fuse over here, this is the AC plug-in. It goes into the fuse, it comes out from the fuse, it goes to my control circuit, comes out from the control circuit, then enters my switch, power switch, before it now gets to the transformer. This configuration enables this control circuit to control when this transformer comes on. And as we can see here, the front is now 100% ready. This is the front side. What we have here is an AC voltmeter that enables us to know or to see the voltage range at any time. Yes, and this switch over here is basically, I call it a current switch. It switches the rate of current that comes out of these charging terminals. These are my charging terminals. The positive charging terminal that goes to the positive side of the battery. This is the negative charging terminal that goes to the negative side of the battery. Here I can control the current that will come out from this. When the switch is at this point, the charger produces about 6.6 amps, and when this switch is over here, it produces about 6.6 times 3, which is around 20 amps, and that is what will be available here. So when I'm charging smaller batteries below 50 amps, I should put it here. When I'm charging bigger batteries from 100 amps or above 50 amps, it will be here. And this is my power switch, which powers the whole system. Once this is on, power will now be available here. And don't forget that this is an automated charging system, meaning that this charger determines when to start charging the battery that is in place. If the battery is connected to this terminal, the system will first of all scan the battery to see the level of charge available in that battery, and it will now make decision on when or whether to charge the battery or not. And if after testing or scanning the battery, if the charge level is high, if the battery is full, then the charger will not put another extra charge on that battery until the battery goes down to a certain calibrated voltage that I have set on this system. So as you can see, I'm through with my vent drilling. Has double vents for effective cooling, and of course a cooling fan at the back that will suck air into the system. So basically we will now have to run a test and see how it works.